Okay, so I have here a video on the one-way ANOVA, and this is looking at the cars miles per gallon data, and we have 3 different sizes of cars and measurements on what I guess is average miles per gallon for these different types of cars. Now, there's 3 types, not 2, so we can't just do an independent samples t-test. And what I want to do is I want to run an ANOVA, but let's show you something. So ANOVA is under Analyze, Compare Means, and one-way ANOVA. This is for the one-way ANOVA, kind of similar to chi-square. There's going to be a more complicated test next week, but for now we're just doing one-way ANOVA. And what that means is that there's just one factor, so sizes are only factor. When I pull up one-way ANOVA and I try to run this, it's not correctly interpreting the size variable as a categorical or a factor variable. It's coded correctly. It's coded as nominal or ordinal. It's coded as nominal, but we can't use it as a factor. And so you're like, how am I going to run my ANOVA, right? That kind of sucks. So there's actually a trick to this, as there's many tricks in SPSS. It's like the land of tricks, which is to go under Transform. And admittingly, this is the first time I've ever done this, but transform and then automatic recode, okay? Transform and automatic recode. And so we want to do the automatic recode, and we want to do it with size. And what we want to do is we want to change the data type a little bit on this. Apparently, the way to do this is to do a new name. I'm going to do size number, okay? And it's going to recode starting from lowest value to highest value. And what it's supposed to do is recode this as it's a string, so it's going to be coded as a scale variable. I think that's when it can happen. Let's treat links, apply template. It doesn't, oh, add new name. Okay, so add new name, there I go. And I think this is going to work. Let's try this. Hit go. Okay. All right, good. Oh, perfect. So now it has it as a numeric variable, and let's see the difference here. Beautiful. This is actually very nice what SPSS did for us. It took the size variable, which is a straight string, and it actually did the coding. We talked a little bit about this coding before. And coding means that you're using numbers to represent string variables. So the number 1 represents luxury, 2 represents sedan, and 3 represents small. So this is actually kind of a neat thing because we can use this if SPSS has something that isn't a string data type and make a numeric data type. And this is really not, this is not ANOVA. This is because it's a quirk of SPSS and the way that SPSS runs. And that when we run ANOVA, we have to have data in certain types. And so your data, now the measure is still nominal for regardless of whether it's string, but string and nominal is different than numeric and nominal, the way that they're coded. So it's just a data encoding issue, not an ANOVA issue, but the trick is to go under and do that transform and automatic recode. And I don't know why you have to do that. It really wasn't my idea at all. I think it has something to do with SPSS being old software, and like I've said before, it's kind of like old versions built, the newer versions rather are built on the old versions. It's kind of like when you have an old house and remodel it, which is kind of my house. So you kind of have like, you know, an old foundation and a new kitchen, and you kind of have to make them compatible and play around with things. But so that automatic recode changes the data. It takes the data and basically creates another variable with data type. You can't and you really don't want to overwrite the original data. So you don't want to just bag the original size data and overwrite it. You rarely, if ever, want to overwrite original data. That's just not something you ever generally want to do. If you do that, you want to like save it as a new data file and keep the old data file. When you're analyzing data, overwriting data is not a good idea in general. You're better off keeping, you know, a gazillion columns, maybe just transform again or whatever, than overwriting it. Anyways, back to actually running the ANOVA. So let's go under Analyze, and then Compare Means, and then the one sample t-test we've done, the independent sample t-test we've done. The paired t-test we've done. These other two I don't really play around with. I don't know exactly what they do. I think the means will actually run somewhat of an ANOVA. Let's actually play with that. It actually will, by the way. So I could have, if I hadn't recoded, I could actually use this a little bit. This runs kind of sort of an ANOVA. Not really. Let's just see what this does. Okay. Independent is our X, so that's going to be size. And then dependent is going to be our Y. And then hit go. This is on the original variable. There's some old chi-square stuff in here I need to clear up. Not really. So all this is actually doing is it's calculating the means of the different types of cars. I thought, though, that this also did sort of a mini ANOVA, from what I remember. There's got to be a feature to click. Options. Let's see what we got. ANOVA table and ADA, yes. So there is, sorry, I didn't practice this before, so I'm just doing stuff from old memory. So there is, in fact, a way to do kind of a basic ANOVA. Now, this is not as good as the other version, but if we were lazy and hadn't recoded like we just did, we could actually get an ANOVA table out of this. Oh, this is interesting. So it does, in fact, run an ANOVA table. So you could have actually, in other words, you could have taken the original data and lazily not recoded it and done compare means and done this means, just this means feature, but you would have to know to go under options and then check off ANOVA table. That's interesting. And so again, we see some redundancy in SPSS. But anyways, the way that I was really going to show you is under analyze, and this is the way I want you to use. Analyze, compare means, and then one-way ANOVA. Okay? And then the X variable is going to be the MPG. Now we're using, rather the dependent, that's kind of the Y variable. I shouldn't say it's the X variable, that's a Y. The X variable is really your factor. Which is going to be your recoded size in that numeric nominal form. And then this is all set to go and hit go. And you're going to get the same exact table for the most part. The only difference is this one is displayed. You can see the redundancy in SPSS because the ANOVA table is exactly the same, but sort of like the way it's formatted and stuff is a little different. So this is like an older version of this, but there are two different ways to run it. So either way, you get your ANOVA table, and you see that there's a significance of 0.038, which is, it's not tremendously different, but we see that there's a difference in the different miles per gallon based on the different cars. And actually, this little means table is kind of handy because it tells us that actually the mean miles per gallon for the luxury vehicles is the lowest, and then the small cars is the highest, which is what we'd expect. But it doesn't, it tells you, overall, the ANOVA is telling us that there's a significant difference here. It's probably between the luxury and the sedan, but you can't, the luxury and the small, but you can't really tell exactly where the differences are. ANOVA just tells you that there's an overall difference, okay? So that was running the one-way ANOVA in SPSS. Again, the methodology is redundant. You can go under Analyze, Compare Means, and do Means. That I could have done with the original data. The transform data was for the one-way ANOVA. I believe this is the more updated version. The reason I want you to use the one-way ANOVA, this one, and not the first one, is that the next thing we're going to do, you can't do with this feature, but you can only do it with this, and that's the post-hoc analysis. So that's the next video. So there is a difference in, like, this one. The newer one has better features, and so recoding your data is worth it for that. So that's the basics of how to run the ANOVA, which is, of course, a comparison of means from two or more groups. Typically, if we only have two groups, we're just going to do the independent samples t-test. But if we have three or more groups, then ANOVA is the way to go.